Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge. Unique paths. There is a robot on an M cross N grid. The robot is initially located at the top left corner, that is at grid of 0, and the robot tries to move to the bottom right corner, grid of M minus 1, N minus 1. The robot can only move either down or right at any point in time. Given the two integers m and n, return the number of possible unique paths that the robot can take to reach the bottom right corner. Okay, the test cases are generated for the answer will be equal to less than or equal to 2 into 10 power 9. So we are given a m cross n grid. There is a robot starting from this first position, and it should reach the end of the position, that is the last cell of the grid. We are not having a grid, we are just having their sizes m, their rows and columns m and n. So we can take any possible solutions, we can go for any possible solutions, either left or either only to either down or right at any point in time. So let us come from the last cell of the position to reach the first cell. So from the last cell of the grid, what directions it can go? Either it can go up or it can go to its left. So these are the two possibilities to move the robot from that particular cell. So let us have a recursive function. I will name it as get paths. This is going to give me the number of paths of this robot. It starts from m minus 1 and n minus 1. So we can have a private function int get paths. This is going to return me the paths. I will name it as int I and int j. What is the base condition? If my I reaches my 0 and j also reaches my 0, that is I and j is 0, which is at the first cell of the grid, then I can just return 0, then I can just return 1, because I have found one path that starts from this last cell of this grid and it reaches to the first cell of the grid. So this is one path that I have reached. So if this is not the case, there is another case where I and j can reach the boundary. So we will have a boundary case, that is if my I is 0, that is I is less than 0, or my j is less than 0, then this is a boundary case, so I will just return 0. Or else I can take either two options. Either option 1 is nothing but up direction I can go. So I will call the same recursive function get paths. In up direction to go, I want to reduce the row, so I minus 1 j stays the same, and I can go for down direction, sorry, down, not down, up and left direction. I can go to my left direction and I can call the similar function I, and j will be reduced to 1, and finally I want to return up plus left. This way gives me the total unique path that the robot will reach from the end of the grid to the first position of the grid. So let us run our code and see how is it running. So it is giving our correct answer, but this will give a time limit exceeded, since we are exploring all possible paths. There will be overlapping sub problems, so we can reduce reduce that time complexity. It is exponential in nature, so we can reduce this time complexity by using dp. So how we can use this dp? We can see what are the changing parameters. There are two parameters that are changing. So we want to declare a 2D array. So 2D array we will name it as dp of size m, and of size n. This is a m cross n matrix. I will declare initially all -1, and I will pass this dp as well, and we have to pass this dp here, and we have to pass this dp here, and we have to pass this dp in the function call with reference, since it should the changes should affect. So dp of I and j is equal to up plus left. We have cached this solution, cached this case, and also we have to check another case. If my dp of ij is already computed, it is not -1, then what I can say is I can just return my dp of ij. So now I have cached the solution. Let us use the example test cases and just run our code. It got accepted. Let us submit our code. The time complexity here will be order of m into n, and the space complexity will be order of m cross n. So we can further optimize, and there is an auxiliary stack space that we are using here. Since it is a recursive function, we will be using an auxiliary stack space. So let us write our approaches here first. So first, recursive approach. Here the time complexity will be 2 order of 2 power m into n, m cross n, and the space complexity will be exponential. So we have memoized this solution, and we have reduced the time complexity to order of m cross n, and the space complexity is also reduced. Here we are using an m cross n grid, plus we are also using an auxiliary stack space. Order of the auxiliary stack space will grow up to m cross n itself. The auxiliary stack space will grow up to max of m and n, max of m comma n. So this is an auxiliary stack space, but we can reduce this auxiliary stack space by doing a tabulation method. If we do the tabulation, then the time complexity will be order of m cross n, and the space complexity will be also order of m cross n. So let us do our tabulation method. How will be the tabulation method is, we have to initialize this to 0 itself, and we have to see the base condition, where the base condition is deep when I and j is 0, then we are just having 1. So let us say name I dp of 0 and 0 to be 1, and in our recursive call we are going from m minus 1 to 0 and n minus 1 to 0. So to convert it into a tabulation, it is just an opposite method. So I will be going from 0 to m minus 1, and j will be going from 0 to n minus 1. Already this 0 and 0 is computed, so let us start from 1 to 1. So this will be our for loops. So let us declare the for loops. Int I is 1, I less than m I plus plus, and another for loop dp of for int j is 1, j less than n j plus plus. So yeah, we have to just copy this recurrence relation into our code. Let us take this return statements. This conditions are not needed, and this get paths is nothing but dp of I minus 1 j and similarly this get paths of I j minus 1 is nothing but dp of I j minus 1. And finally after calculating dp of ij is nothing but up plus left. So finally we'll be returning dp of m minus 1 n minus 1, and this will be our tabulation method. We can just take this function. Let us run our code and see whether it is running or not. We are getting some wrong answer. Let us see what is happening here. So why it is wrong answer? Let us see what is happening here. So in our base case dp of 0 is 1, but actually it should consider there is only one row here. If there is only one row, to reach this position it will be 1, to reach this position it will be 1, so to reach this position it will be 1. So whenever I and j is 0, we have to calculate, we have to set dp of ij to be 1. So if I is 0 or my j is 0, then we have to set dp of ij to be 1. Then we can start this from 0 itself, this for loop from 0 itself. I think we don't want this base case, and let us continue once we done this, or else we can also have an else part, and then I think it will be sufficient. Let us run our code and see. Yeah, it is getting accepted, and this is the tabulation method, and the time complexity here will be order of m into n, and the space complexity will be order of m cross n. We are not using any extra space here, we like auxiliary stack space we are not using here. And this is the problem from coming from recursive, then memoizing it, and then the tabulation approach. Hope you like this problem. And we can also further optimize this space complexity. We are here the in tabulation it is m cross n. We can also further space optimize this solution. If we, since we are using only the previous rows elements, so we can have two 1D array, which is, I will name it as cur and previous, cur with n with column size, and it is initialized to 0, and previous which is column size and it is initialized to 0. And wherever we are seeing dp of I, it is nothing but the cur, and dp of I minus 1 it is previous, and this dp of I is nothing but the cur, and dp of I is cur. And after this for loop we want to reset this previous is nothing but my cur, and dp of m minus 1 is nothing but either previous or cur. So by using two 1D arrays we can just do space optimization, and yeah, it got accepted in our example test cases. Let us submit. Yeah, it got accepted. So we are just using a 1D array to do this. So here the time complexity will be order of m cross n, and the space complexity will be order of n only, since we are using only 1D arrays, two 1D arrays. So hope you like this video. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.